Hey guys, so you have made it through Unit 8, Lesson 1, 2, and 3, hopefully so far. I haven't done a tutorial over Lessons 2 and 3 because there really isn't any math involved in those. And so if you finished Lesson 1, you can go on and progress through Lessons 2 and 3. And then I'm going to explain how to do the math in Lesson 4 at this point. So to kind of summarize some of the vocab in this lesson, the electrode where oxidation takes place is called the anode. And the electrode where reduction takes place is called the cathode. Okay, and there's going to be some problems here, and these are kind of the steps for those problems if you want to screenshot this. And this is the actual formula right here that we are going to use. So I'm going to refer back to this in just a minute. But let's read the first question here from your lesson. It says, given this information, what is the anode and what is the cathode? Okay, so the first thing you're going to do is you're going to write the reduction reaction for both of those pieces of information. So for example, the reduction reaction from the Mn or manganese, it went from 2 plus, you see that? Somehow it went from there all the way to Mn, just like that. And when an element is by itself, its oxidation state is 0. So this is the reduction reaction for it. It must have dropped off 2 electrons because, or it must have accepted 2 electrons here so that it can get to an oxidation state of 0 because electrons are negative. So something with a positive 2 charge, when you add 2 negative things to it, it's going to balance out to 0. And now we're going to write the reaction for the copper. Cu2 plus, same thing, plus 2E makes Cu0 because it started at 2 plus and then it went to a regular copper at 0. So it must have dropped off 2 electrons. So now that we've written both of these out, we've written the reduction reaction for both, we're going to look them up in our chemistry reference guide. So we are going to go, I think it's table like B16. Let me see. Yeah. Okay, table B16, page 64. We're going to find the exact reaction that we wrote down. So again, we're looking for Mn plus 2E. Okay, sometimes these can be hard to find. So I'm going to struggle with you guys here. Okay, here it is right here. Mn plus 2E makes Mn, right? So this is our reaction right here. And it looks like its value is negative 1.19. So I got to write that right here, negative 1.19, and the unit there was a volt. Okay, now we need to find it for the copper. Cu2 plus 2E. Okay, it looks like it is right here. Cu2 plus 2E, and its value is 0.34, positive 0.34. Okay, so now that we have both of these, the substance with the lowest value is the anode. Okay, so the lowest value here is the Mn. So the Mn is our anode. I'm going to write that to the right over here. But the Mn is the anode because it has the lowest value. Okay, so the answer to this, they want you to write it in its most positive state. So the anode is Mn2 plus or C. Choose it in the most positive state. And the cathode as well is Cu2 plus or D. So choose it in its most positive state. Okay, so again, you just write the reduction reactions, find it on the data table, and see which one has the lowest value. And the substance with the lowest value functions as the anode, and you choose the one that's most positive. The follow-up question it asks is the same situation, but now it asks, what is the E of the cell? Okay, so the formula for that is really easy. E cell is equal to the E of the cathode minus the E of the anode. And we already looked that up. The E of the cathode was 0.34, and the E of the anode was negative 1.19. So this is going to be positive 0.34 minus a negative 1.19. I'm getting nervous that I didn't copy that over correctly. Yeah, 1.19. So minus a negative, that's a positive, right? So it's 0.34 plus 1.19 to get 1.53 volts. Okay, let's try the next one. So we're going to do the same steps. We're going to write out the reduction reaction. So it went from CO3 plus to not regular CO, but CO2 plus. That means that it must have just dropped off 1 electron. or I mean added on 1 electron, because 3 plus a -1 makes 2, right? So, or 3 minus 1 makes 2. So that's our first reaction. And the second one is Ni2 plus makes regular Ni, which is 0. So it must have dropped off 2 electrons, because 2 minus 2 makes 0. 3 minus 1 makes 2. 2 minus 2 makes 0. Okay? Now we're going to find them in our guide. So we're looking for CO3 plus E negative. So I'm finding that right here, and I'm getting positive 1.92. Positive 1.92. And now the nickel, Ni plus Ni2 plus 2E. So I'm seeing that right here, Ni2 plus 2E. So that's negative 0.26. 0.26. Okay. So the substance with the lowest value is the anode. Okay, the substance with the lowest value is the anode. So our lowest value is nickel. So nickel must be the anode, and cobalt must be the cathode. Okay, so our answer is going to be the cathode is CO, but remember you choose the one that's the most positive. So CO3 plus, and then our anode is Ni2 plus. Okay, so that would be C and E for that. Okay, and now it asks us to calculate. So again, we're just going to do E cell equals E cathode minus E anode for this part. So for the next question after that, it's going to be 1.92 minus negative 0.26. Okay, so 1.92 plus 0.26 is 2.18 volts. So the answer to the second part is 2.18 volts. Next question, I'm going to let you guys try number 16 because this one doesn't seem to have any hiccups in it, so it's a good one to practice. So 16 and 17 are together on that. It's the exact same as what I just did, so you can rewind or put it in slow motion or whatever you want to do. I do want to do this one because this can trip some people up. So this is F2 and then Cu2 plus. We're going to write the reduction reaction for both. So it looks like F2 went to, that's a weird F that I drew there, F0, right? Or I'm sorry, F negative 1. Do you see that negative sign there? Okay, right here. So the F2 started at 0. Like when an element is just plain by itself, it's 0. And then it went to negative 1. So it must have added 1 electron, right? Because 0 minus 1 is negative 1, right? So that works. That's just a little bit tricky. And then the Cu is normal. It went from 2 plus to regular 0, so it must have dropped off 2 electrons here. And now we proceed just as normal. We need to find both reactions. So let's see if we can. Here's the F1 right here. The nice thing is that the reactions are all here. So you're going to have to find it somewhere here if you're like wondering if you did it right. So I'm getting positive 2.87 for this one. And for the copper, Cu2 plus 2E, I am getting 0.34. It's this one right here. It's not really letting me highlight it. Oh, I didn't realize I wasn't sharing my screen. I'm getting this one right here, 0.34 for this one. 0.34. Okay, and so my anode, they're both positive, right? Yeah. So my anode is going to be the copper because it's the lowest one, and this is going to be my cathode. And so it asked me to calculate it. So it's going to be the E is equal to E cathode minus E anode. So it's going to be 2.87 minus 0.34. 2.87 minus 0.34, and I'm getting 2.53 volts. That's one right here. And I kind of asked it out of order, so we figured out that the cathode was F2 and that the anode was Cu2 plus. Remember, you're choosing the most positive version of it, and F0 is more positive than F negative 1. So these are just some examples. I think there were a couple more on there, but I wanted to give you a frame of reference for these, and join my classroom if these don't make sense or if you have any follow-up questions on it.